I now want to look at cylinders and what these really mean mathematically. To start, let's consider the equation x squared plus y squared equal to 1 in 2 dimensions. Well, this is going to be a circle. Its center is the origin, and its radius is 1. But now the question is, what if I graph this in 3 dimensions? In 3 dimensions, we still expect to see the circle whenever we're on the xy plane. But z should be able to be any value we want it to be, so I should be able to go up and down as much as I want. And when we do that, we end up with this idea of a cylinder. And in everyday language, a cylinder does refer to a shape with a circular cross-section like the one I drew here. But the mathematical definition is more general. When I consider this equation x squared plus y squared equal to 1, we know that the point 1, 0, 0 is on this graph. But we can also say that so is the point 1, 0, z, where z is any number. So what that tells me is that the entire vertical line through the point 1, 0, 0 will be on the cylinder. The cylinder is the set of points swept out by translating that line around the circle in the xz plane. The idea being I have my circle in the xz plane. I draw one vertical line through this point 1, 0, 0, and then I just take this vertical line and I move it around the circle. And as I do, I will map out this cylinder. And generally speaking, a cylinder is any surface that does this. Any surface that is generated by translating a line over a planar curve. The line that we translate in order to generate a cylinder can extend in any direction. And the curve along which we translate, it can lie in any plane. So let's look at some examples of this. To start with, let's consider the graph of z equal to cosine x. Here, I have the graph of z equal to cosine x on the right, and on the left, the actual equation z equal to cosine x in 2 space, where I have my x and my z will be the vertical axis. And the idea is this point that I have marked on this graph is going to correspond to this line in 3 dimensions. I'm actually mapping out a line that passes through that point. And as I move this point along the graph z equal to cosine x, that line is moving along the graph in 3 dimensions. And this is the idea of a cylinder. I have a single line that maps out my surface as I graph it along a given function. Next, let's consider this function here, z plus y minus 2x times x minus 1 squared equal to 0. And to start with, I'm actually going to rewrite this as z is equal to 2x times x minus 1 squared minus y. So let's look at the graph of this and see if we can determine that it is in fact a cylinder. Here's the graph of this surface right here, and I can see this line drawn diagonally across it, and this would be the line that I am using to map out. So it does not have to be perpendicular to one of my axes. In this case, I have this diagonal line that I can move to map out the surface of this particular graph. So this would also be a cylinder. We can determine that something is a cylinder by just looking at its equation. And there are 2 things that would tell us that something is a cylinder. The first way is that one variable isn't included in the equation. As an example, my z equal to cosine x. Y is not included in that equation, so this would be a cylinder. The other way is that 2 variables are linear. This would be my equation z plus y minus 2x times x minus 1 squared equal to 0. In this case, I can see that the z and the y are both linear, which would make this a cylinder.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.